Problem number 5. A team of surgeons has developed a new technique for an ear operation to restore the hearing of people. Under the old method, it is known that only 40% of the patients who undergo this operation recover their hearing. Suppose that surgeons in various hospitals have performed a total of 364 operations using the new method, and that 158 have been successful. Using zero point zero 0.01 level of significance, can we justify the claim that the new method is better than the old one? First step is to identify the null and alternative hypotheses. If you can notice in the second sentence of this problem, a factual statement about the old method is stated. So this will be our basis for the null and alternative hypotheses. So for the null hypothesis, we have the population proportion is equivalent to 0.40 since it is stated that we have 40% of patients who undergo the operation recover their hearing. And then for the alternative hypothesis, we have the population proportion is greater than 0.40. Ngayon, ma'am, where did you base the greater than? Kasi po, in the last part of this problem, we have the phrase na the new method is better than the old one. So, di ba po, if you have a better result, then and numerically speaking, we must have a greater percentage of recovery. So that's why we use the greater than symbol because of the term better. Second step, we identify the alpha level and the tail test. The alpha level is 0.01 or level of significance is 0.01. And we will have a one-tail test since the mathematical symbol used in the alternative hypothesis is greater than symbol. Step 3, identify the statistical test that you're going to use for this given word problem. And since the values given in this problem is in proportion, then automatically this problem is under C-test for proportion. This is under C-test for proportion because we have the phrase a total of 364 operations using the new method and that 158 have been successful. So this is a representation of proportionality statement. So the statistical test is C-test for proportion. Step 4 is the computation. We must identify the given values first before we can solve. For the sample proportion, our basis is the proportionality statement, and we have the total number of values as 364 and the number of x is 158 or parang like respondents, something like that. So the sample proportion is equivalent to 158 over 364. Rewriting the fraction form into its decimal form, 158 over 364 is 0.43 in decimal. For the population proportion, we have 40%, so that is 0.40. Next is the value for the Q with the formula 1 minus P. Substituting the value of P, we will have 1 minus 0.40 or zero point 0.4. Simplifying, the value of Q will be 0.6 or 0.60. Now that the values are complete, we can now substitute in the given formula for z-test of proportion. Substituting, we will have 0.43 minus 0.40 all over the square root of 0.40 times 0.60 all over 364.
For four-liner calculators, fraction, and then 0.43 minus 0.4 all over the square root of fraction 0.4 times 0.6 all over 364. Equal sign, that is the answer. For two-liner calculators, open parentheses, 0.43 minus 0.40, close, tapos fraction, and then open, then square root, tapos open ulit, then 0.40 or zero point 0.4 times 0.6 or 0.60, and then close, then fraction, then 364, dalawang close, equal sign. That is the answer po.
The final answer for the C computed is 1.17. Step 5 is the decision rule. Reject null hypothesis if the absolute value of Z computed is greater than or equal to Z tabular. We already know the Z computed. Next is to get the value for the C tabular. And for us to get the values for the C tabular, we have to go back to our step 2 to identify the alpha level or level of significance and the number of tailed tests. Going back to step 2, we have the level of significance is 0.01 and 1 tailed test. Meaning we have to draw an imaginary vertical line passing through 0.01, and we have to draw an imaginary horizontal line passing through one tailed test. And the intersection of the horizontal and the vertical line is the value for our Z tabular. Substituting the values for Z computed and C tabular, we will have the decision rule as reject null hypothesis if the absolute value of 1.17 is greater than or equal to the absolute value of 2.33. Step 6, identify if we have to reject the null hypothesis or we fail to reject the null hypothesis. Let's go back to step 5 and check whether the mathematical statement is true or false. So we have the absolute value of 1.17 is greater than or equal to 2.33. Extracting the absolute values rather, we'll have 1.17 is greater than or equal to 2.33, which is obviously false. So meaning to say po, we failed to reject the null hypothesis. Next step and last step for this given problem is the conclusion. Since we failed to reject the null hypothesis, the basis for our conclusion is the null hypothesis. And going back to step 1, we have the null hypothesis as the population proportion is equal to 40%, which means that the new method is the same with the old method.